Let's do one more example of inverse derivatives. This one will be trig. So remember our formula, f inverse prime of x equals 1 over f inverse of x, and then we take f prime of that. Now let's say our function is sine of x. Then f inverse is just arcsin of x. And the derivative of sine of x is cosine of x. So we plug that into our formula. We say arcsin of x prime, that's just this piece here, equals 1 over, plugging stuff in, arcsin of x, and we take cosine of that. That's pretty much a successful use of the formula, but now we can do some trig. So remember that when you see arcsin of x, it means the angle whose sine is x. Let's call that angle y. So sine of y equals x. Now we can model that with a right triangle. Let's draw one now. Draw a triangle here. Let's say the angle is y. It's a right triangle. We'll say the opposite side is x. Hypotenuse is 1. So since sine is opposite over hypotenuse, this makes sense. Now we can use the Pythagorean theorem to find the adjacent side. So adjacent equals square root 1 minus x squared. So cosine of that same angle is cosine y equals adjacent over hypotenuse, and that equals square root of 1 minus x squared. And because y equals arcsine of x, we can say cosine of arcsine of x equals the square root 1 minus x squared. So the final answer, arcsine of x prime equals 1 divided by square root 1 minus x squared. There we go. Really, the easy part was using the formula, and then we just have to remember some trig identities to do that bottom part down there. Okay, if you like this, give me a like, give me a follow, comment, share, save, do all that stuff. I really appreciate it. It helps a lot. I'll see you for the next video.